This is 7.2 trigonometric integrals. So this section is going to involve powers of sine and cosine. So there's a few different cases. The cases are when the power of cosine is odd, then that means we're going to save one cosine factor and then use the u substitution to be sine. In the case where sine is odd, we're going to save one factor of sine and use a u substitution of u equals cos. And in the case where they're both, sine and cosine are both even, then you have to use these identities. So let's look at the first example. In this case, we have sine is odd. So you go over here, it says sine is odd. That means we're going to save one sine factor. So we're going to rewrite this as the integral of sine squared x cosine squared sine theta d theta. So as you can see, I saved one factor of sine and I moved it off to the side. So instead of cubed, it's now squared because the other one is over here. All right, and now our u substitution is going to be cos. That's what it says here. So u equals cosine of theta. And then when you differentiate, you get du is equal to negative sine theta d theta. But the negative, we want to move it to this side since there's no negative here. So I'm going to divide it and move it to the left side. All right, and now this part will get substituted out for this part. And then this will become u squared. And this, we can rewrite that using the identity. Sine squared theta is equal to 1 minus cosine squared theta. Okay, so let's rewrite our integral. So the new integral will become, this will become 1 minus cosine squared, which is really 1 minus u squared, because cosine is u. This will become u squared, which is really u to the 4th power. I really didn't have to do this squared. I didn't have to do that. I thought I was going to have to do that, but I didn't have to. So this could have just remained to the 4th power, just like this. All right, and now this gets replaced with negative du. So the negative will be out in the front, and the du will be over here. All right, now we can distribute. I'm going to distribute the negative and the u to the 4th. So the new integral will now be written as negative u to the 4th plus u to the 6th du. And now we can take the antiderivative, which would be 1/7 u to the 7th minus 1/5 u to the 5th plus c, the constant of integration. And the final step is to replace u with cosine theta. So that will be our final answer, 1/7 cosine to the 7th theta minus 1/5 cosine to the 5th theta plus c. And that will do it. So that's one example. Let's move on to the second example. All right, here's another one that involves sine and cosine. This time, both powers are even. So when they're both even, we need to use these two identities. Sine and cosine are even. We have to use these identities. So let's go ahead. Sine involves the minus, and cosine has the plus. So if we rewrite this integral, it should be written as 1/2, 1, what was it, plus or minus for sine? For sine, it is minus cosine of 2x times 1/2, 1 plus for cosine dx. All right, and now the two 1/2s can be written as 1/4 out in the front. That's a constant. And then if we multiply these out, we expand them by multiplying, you should end up with 1 minus cosine squared 2 to the x dx. And because you still have a square, you're going to have to use the identity yet again, this identity. But because this is a 2x, when you plug in 2x into x, that becomes 4x. So we're going to use the same identity, but this will now become 4x because of the 2x here. All right, so this is going to look like this. 1/4, 0 pi over 2, 1 minus 1/2, 1 plus cosine 4x. I'll change those to brackets with respect to x. Now we need to distribute the negative 1/2 and combine like terms. So if we do that, that's going to look like this. It's going to become 1/2 minus 1/2 cosine 4x. Okay, now we can finally take the antiderivative. It's going to be 1/2 x minus 1/8 sine 4x. And we're going from 0 to pi over 2. All right, now we substitute pi over 2. That's going to be pi over 4 minus 1/8 sine 2 pi minus, notice that when you plug in 0 here, that becomes 0. And if you plug in 0 here, that's also sine of 0 is 0. So it's just going to turn out to be 0 for the bottom limit. And this also turns out to be 0. Sine of 2 pi is 0. So this cancels out. So the final answer is just going to be 1/4 times pi over 4, which is pi over 16. That is the final answer. All right, the next type of problem you'll see is powers involving tangent and secant. So similarly, there's a couple different cases. If secant is even, then you want to save a factor of secant squared, and u becomes tan x. In the case where tangent is odd, you want to save a factor of secant tan, and you want to make u equal to secant x. So let's look at our first example involving tan and secant. So notice that tan is squared. So it says if tangent is squared, if secant is even, which it is, secant is even, then we're going to save a factor of secant squared, u becomes tan. So let's rewrite that integral as tan squared, secant squared theta. We're saving a factor of secant squared off to the side, and our u becomes tangent theta. The reason we have u equal to tangent is because when you differentiate, you're going to get secant squared theta d theta, and there is the substitution that's going to take place. That's going to replace that. All right, and since u is tan, this will become u squared. We're going to have to use an identity for this. The identity that we're going to use is the following. I'll write it over here. It's going to be secant squared theta is equal to tan squared theta plus 1. So that's the identity we're using to replace secant squared. So this will get replaced with this expression. So let's rewrite the integral now. Tangent squared becomes u squared. Secant squared will become u squared plus 1. And this becomes du. All right, now we can distribute and integrate u to the 4th plus u squared with respect to u. All right, and then the antiderivative is 1/5 u to the 5th plus 1/3 u to the 3rd plus the constant of integration. And our final step is to replace u with tangent theta. 1/5 tangent to the 5th theta plus 1/3 tangent to the 3rd theta plus c is our final answer. All right, let's look at the next example. This one involves odd powers of both tan and secant, so let's see what they want us to do there. In the case where tangent is odd, you want to save a factor of secant tan, and u becomes secant. All right, so secant tan is what we save to the side. So this now becomes tan to the 4th, which I'm going to write as tan squared squared And this is going to become secant squared times, now we have a secant tan. So this was a fifth power, and now it's a fourth. This was a third power, and now it's a 2. And here are the other 2 that were saved to the side. So these will be replaced or substituted for. All right, and for this one, we are going to use the identity tangent squared of x is equal to secant squared of x minus 1. These are good to have memorized or have on a formula sheet next to you when you're working out these problems. All right, so let's rewrite everything. Our u substitution is going to be secant, because the derivative of secant is secant tan. Which is perfect. That's the reason why we saved those 2 factors off to the side, because now we can substitute for that. All right, so rewriting everything will look like this. So this will become u squared, and then this is going to replace this, so that'll be u squared minus 1 to the second power. So let's rewrite everything. So tangent squared is going to be secant squared minus 1, which means u squared minus 1 to the second power. Secant squared becomes u squared, and this entire factor becomes du. All right, now we need to expand this part before we distribute. So if you expand, it will become u4 minus 2u squared plus 1 u squared du. And after you distribute, that'll become u to the 6th minus 2u to the 4th plus u squared du. And then after you integrate, you should end up with that. However, we still need to replace our u with secant. So let's do that now. It looks like I'm running out of space, so I'm going to write my answer up here. 1/7 secant to the 7th minus 2/5 secant to the 5th plus 1/3 secant cubed x plus your constant of integration. Kind of ran out of room there. All right, so that is our final answer. Let's look at the final problem. Actually, no, we are done.